Howdy everyone and welcome to LE4. Today we're going to go over the expectations, the functionality that's required, and the starter code that you're going to need to use for LE4. So some background and motivation behind LE4 is that we want you to experience the importance of threading and therefore synchronization. So making sure that the threads talk to each other correctly is important. So we are going to mock a bank account and transactions into the bank account. So deposits and withdrawals, three different ways. So one is fully synchronously. So you're only going to be using one thread. The second is we're going to be using multiple threads, but it kind of becomes a free-for-all since we don't use any synchronization. So you'll have threads that are saving off an old value, modifying it while a different thread is modifying it at the same time. So you get really interesting synchronization issues that way. And then we're going to be using multiple threads and adding on synchronization, also known as locks or mutexes. More or less. There are different flavors, but we're going to be using mutexes specifically. Okay, so like I said, the goal is we're going to start three of our sections, each with a balance of 0, run all of the transactions, and then output what each section believes is the answer, along with the time it took each section to run. And we'll be using the transaction.cpp file. You'll see it in your starter code. It is fine to hard code this. We won't be changing the value, so we don't need an input. Okay, so this is where we're going to get into the starter code, but we, in our main function in teller.cpp, we have these 3 sections, where section A is the fully synchronous one, where it all runs in one thread. Section B is where it runs in multiple threads, but it's a free-for-all. And section C, we're calling a thread safe function. Thread safe is where you have told the users that it is fine to have multiple threads running the same function at the same time. Cool. Let's take a look. So if we go into our starter code, this is teller CPP is the main file that you'll be editing, but there is one function that we're going to edit in bank account that we'll go into a bit later. But you can see at the top where we're saving off the file name. Number of transactions, we're capping this to 2,000 because 2,000 is the maximum number of threads that GitHub Classroom allows us to run. Okay, so then we scan the input file into the trans array, then closing. So now when you come to here, these are the sections. So approach 1, section A. You can see it's grabbing the start time, performing each transaction just using bank account.transaction and giving it the value, going through each transaction and printing the results. This is done for you. It is for your reference when you're looking at the other sections. So in the second section, we're saving off the start time, but what you will need to do is to create the thread. So you'll be using the same loop as we did before, where we need to add a for loop. So we're looping over the trans array. But now we need to create a thread. So the next part, create a thread for each element in the array. And how are we going to do that? We're going to do that by first, let's see what documentation is available for us in the to create a thread. So I always start by recommending you man thread. However, that's not going to work for us in this case. So we'll do the second best option, which is running a Google search, which is fine too. And I will be searching just for STD thread, which is which is the example that I'll be giving you. If you really want, you can use POSIX thread, you can use task, that is fine. But in this case, I'm just going to be using normal thread. And we'll grab the Linux documentation for STD thread, which C++, that's a good reference point. So now we want to specifically look at the constructor. And let's check out the example for the constructor. So you can see the constructor of the threads requires a handler. So that's going to be the function that the thread is going to call, and the function becomes the thread, or at least it becomes the code that the thread is executing. And then any other arguments are arguments specific to that function. And since it's the constructor, it will return a object of type thread. So let's see how that's going to be useful in our approach. So here we can say, so we already have a thread vector. So if we go tvet.pushback, we want to be pushing back an instance of thread. So we're going to call the thread constructor. The thread constructor requires a handler. So our handler is going to be this teller_thread function. And then the next arguments are the arguments to our function. So teller thread requires our bank account. So a pointer to our bank account, as well as the amount. So in our case, our bank account is B, pointer. So we'll grab a reference to B. And then argument. So that's the amount. For right now, we're going to hard code the first element of your transaction array. Since you will be putting this in a loop, it'll be the element of the array for that iteration. Something else I want to note is there's nothing else that we need to do in order to start this thread. Calling the constructor is enough for the thread to start going, to start executing the bank account transaction. We are good. It is running. So once you have exited this loop, all we need to do is wait for all of the threads to return. And that's what this join does. So I like to say that join does for threads what wait does for processes. So remember how in PA2 and earlier LEs, we had to wait for our child process to complete? That's what join is doing. Once join returns, we know that the thread that we have called it on is done, and we have reaped any resources that that thread was using. So that's what this loop is doing. It's waiting for all of our threads to complete. And then we know that we can record our end time and print the results. Okay, so now let's go a little bit in teller thread, and then we can move on to our final section. So teller thread, all it needs to do is call transaction for bank account B. So I'm not going to write any code. It's pretty simple to know what this is doing, and any more code is going to give it away. But you got that. Same thing for bank account or teller thread safe. It's going to be calling the transaction thread safe function. So if we head over to the header file, you've got this transaction that only takes in a underscore amount. And this transaction thread safe, again, it only takes in an underscore amount. So just use the appropriate transaction in your handler. Cool. Okay, so moving on to our last section. So this is going to take the most time. You'll want to perform the same approach as what we just talked about. So you'll be pushing instances of threads to your tvet2 vector. So that's the same, very similar with the joining. Those are all relevant. You should be able to know how to do that. And then once you're done, we do an end and we do a print. So if you're good on section 2, you should be good on section 3, at least on the teller.cpp side. Now we'll move on to the bank account function that we are using. So if we go into bank account.cpp, for the third section, you'll need to modify this transaction thread safe function. And what we want to make sure of is that only one thread is able to do a transaction at a time. So you'll have a lot of threads going, but you only want one thread to be able to perform that transaction. As you'll see when you're running this code, if multiple threads are able to do the transaction at the same time, you'll get really weird issues where your balance is way off what you would expect. So we'll be using this mutex value, M, in order to ensure that only one thread is accessing it at a time. So now I'd recommend you going to the C++ reference one more time. And we're going to be going into our mutex. So specifically in our mutex, we'll be using lock and unlock. So looks like I have to go into mutex. Okay, we'll be using lock and unlock. So lock, make sure that only the thread that we're calling it on is able to proceed. And then unlock allows any thread. Does the reverse. It allows threads to proceed synchronously. Let's see how that works in practice. So if we go to our transaction thread safe, we already have this M value, so we're just going to be calling an M lock. And then M unlock. And let's think about why this works. So say you have 3 different threads, A, B, and C. If thread A gets to line 8 first, it will call this M lock function. Set M state to be locked, and then continue to line 9. When thread B gets to this same code, it will also attempt to acquire the lock. So it will also call m.lock, but it does not return, m.lock will not return until its state is set back to unlock. So it will hang at this line until thread A releases the lock with m unlock. The same thing happens with thread C. So that therefore only A is allowed to perform the transaction. When it unlocks, thread B is ready to go. Same thing happens with thread C. So they're all calling everything through multiple threads, but transaction still happens synchronously with mutexes. You'll get more exercises with this in later PAs and also with your lecture material. Let's see if there's anything else in this PowerPoint. Okay, so we talked about the transaction thread safe function. So transaction thread safe, you will notice it calls transaction. You must keep transaction in here. That you can't work around calling transaction. So it must call this function. And it wraps the call with lock and unlock. Yep. Okay. Again, please reach out. Normal ways to reach out. All right. And yeah, ask questions through Teams. Good luck.